And I just made a decision. One of the major effects that it has, really affected my career has been, first this involvement in urban soils and the soil survey. But I've continued in that I got involved in an international group of which Dr. Paltseva is also extremely involved with, which is called SWEETMA. And with the SWEETMA, we worked together, but with also many other people to do a book called Soils Within Cities that gives a total overview of all the interdisciplinary activities that we've been involved in. So most of my talk will be about that book, but we'll also talk in general about urban soils and within it, my career. So let's start with the first slide. Let's see, can we make it work? What's going on here? We didn't test this part. Didn't have time to test this. There we go. So I first want to, normally when we talk about urban soils, we talk about the tie with how it's related to humans. And we often refer to them as anthropogenic soils, developed by the Anthropocene, which is the current geologic age based on overwhelming human effects on the natural world. And so often you'll hear something called anthropogenic soils. And this is the whole nature of urban soils, but also of all sorts of soils that are affected by humans, to the point that you're starting with a whole new biology and geology and interaction with human. And this will include reclamation, it will include farming, it will include all sorts of aspects of soils besides specifically industrial and development with housing. So why do we study urban soils, or why do we even think about them? Slightly half of the world now resides in cities, and you can see this famous map of the lights in the US, and from that you can see these are totally urban areas, and almost the whole country now can be considered urban on some level, and certainly the US population also is residing in suburbs, exurbs, sparsely settled villages. And in addition to strictly urban with this light map, you also have all the areas where we've mined, where we've altered the soils in agricultural areas to the point that they're not looking specifically like a natural soil, but something different. And those are worthy of study. When I started my career, I worked in agricultural and agronomic areas, but also in forested areas. And I had a very good background in California for field work. I started at the very bottom. As Anya said, I was a lab tech when I came first out of college and worked at Oak Ridge National Lab. And then I moved on to be a soil scientist with USDA doing field work. And I started truly at the very bottom, even though I had a good GPA and I graduated with a bachelor's degree in soil science and plant nutrition. They started me as a biological tech. But and this is something to learn for all of you. Even if you graduate with a master's or a PhD, don't always expect that they'll let you do that level of work right away. But what I always did with thinking about soil survey is I always documented what I did, the processes that I did and what I learned, and I documented it in a paper. And so I worked, and I learned that from working at Oak Ridge as a lab tech, because I wrote papers from my lab tech point of view on research that we had done at Oak Ridge, and in climate change and chemical processes. I actually realized that's one of my talents, is more to write and synthesize than it is to actually do the bench work. And often the scientists that I worked with at Oak Ridge would just elbow me off the bench and tell me, go look at this data and write it up for me. And so I had quite a few papers that were, even as a lab tech, where I wasn't first author, but I had essentially put the information together and reformulated our hypotheses and really thought through what we were doing, and helped those scientists out to clarify the work that they had done. So they saw that talent in me right away. When I went on to being a field soil scientist in USDA, like I said, I started with agricultural and forested areas, but in very complex areas of Northern California with interesting geology, where actually the geology hadn't been mapped. And many, many years later, after we had finished those soil surveys, the geologists actually went back and created geology maps from our soil science maps, which I always think is quite interesting, as well as ecological maps and vegetation maps. And but that's because the nature of soil science is extremely interdisciplinary. Now, when you look at this profile, it's really a classic description or explanation of what you see in urban areas. When I was about 6 or 7 years into my career, and I wanted a position where I ran the show as a soil scientist in a soil survey. And I looked all over California, and there were no positions available. And then I saw a position in Baltimore City, in Maryland, all the way across the country. And I thought, well, maybe I'd have a better chance there than I do where the field is kind of flush and full in California. So I applied for the job, and I got it. And at first I thought it was because I had no competition, but later they told me, no, you did have competition. It was, there were a lot of people that were interested in doing it. But anyway, I went across the country, and I started. Now, the Baltimore City Soil Survey was the first it was the second urban soil survey to be done in the country. The first one had been in Washington, D.C. in 1976, which was an anniversary year. They wanted to do the soil survey of Washington, D.C. as a special kind of event. But there was very few people that had worked on that soil survey, some of them who counseled me, but there was really no instruction. And what I had to do was compare with the experience I had had in California, which actually included a lot of anthropogenic surfaces, because in California they deep rip, they treat the soil like a potted soil almost in the Central Valley, which was one of the places I worked. Plus, I worked in mining areas. And so I had a lot of experience with soils that were all mixed up. And basically, with the soil survey in the US, when it comes to urban soils, it looks very similar to this picture, which is you've got a little bit of natural soil where the trees are, or quasi-natural soil, because those trees are pretty old. So they're probably older than 60 years old. So there's old areas where the soils are undisturbed, and then there's other areas where you can definitely see material that doesn't belong, and surfaces, and you can see in this corner right here, where you've got partially a natural soil, but then down below you've got mixed up material. And so the soil has been disturbed in some way, right in here even. So that was what we worked with, and that was the first discovery, as when I started that soil survey and started to work with it. And basically, this is a good description of what urban soils are all about, is that you have an idealized profile of a natural soil survey, and you have urban soils where the characteristics might be variable horizons, modified soil structure, compaction, waste materials mixed in, interrupted nutrient cycling, low organism activity, or high pH, all sorts of different aspects that aren't quite natural. And here's a good example of a soil survey that has a soil that has a lot of those aspects of a completely mixed up soil. Some are not so mixed up as this. They're very, very subtle. The importance in working with an urban ecology is to understand the effects of urbanization on the soil. And you have to look at all sorts of different aspects of an urban atmosphere. Some of them have to do with urban climate modification, or what we call urban heat islands, where things are much more hot in a city, and they get hotter. Increased temperatures also enhance ozone formation and pollution. In the old days, when we had lead and gas, people didn't realize that lead was becoming through formation of particulates coming in and concentrating in urban areas. The particulate condensation also enhances precipitation, and often there's greater cloudiness or fog or moisture in different ways. And with that, there's also surface runoff increase, evapotranspiration, and water infiltration decrease. So there's so much going on that's different than the natural profile that needs to be considered in thinking about urban soils, and also managing them and mapping them. One of the things that both Dr. Palsleva and I have worked with is the SWEETMA organization. And thinking about the challenges for the urban environment is that increasing urban population produces an increasing demand for food, water, and energy. There's competition for land between agriculture and urbanization, and you all have probably experienced this in Louisiana, where you live, where you see areas just in your lifetime that were empty and now are full of buildings. And climate is a major issue that will probably affect cities more than rural environments, but of course rural environments too. But the rural environments can learn from the cities because it is accentuated in urban areas, but also accelerated. So you can see what's going on and what could happen in the future. And then there is potential for biodiversity degradation or collapse. Something we always talk about is that soils are alive. And in an urban environment, that alive aspect of microorganisms and fungi and the soil's microbiology is degraded within an urban environment, sometimes from pollution, sometimes from compaction, all sorts of aspects. And then finally, human health and social stability are so important in an urban environment and create a huge challenge. And this is something that Dr. Palsleva and I are actually working on a chapter specifically on for another book called Urban Soils. Our chapter will be Urban Soils and Human Health. So we're thinking about it all the time. The working group that Anya and I have worked with in the past, probably I've been involved at least 20 years now, is the urban soils of the working group of urban soils of urban, industrial, traffic, military, and mining areas. And they call this group SWEETMA. soils of urban, industrial, traffic, military, and mining areas. It's a handful. And it was started as an international organization in 1998. But since then, as of 2024, there have been 12 international meetings, of which I always remember that Anya and I met in Mexico about 10 years ago, as well as the Soil Science Society of America. And since then, there have been conferences essentially in all parts of the world. We're still waiting to go to Australia and other parts of Africa than we have in the past, but it's happening all over. And this has created a large group of collaborators and scientists that we work with. And note, yes, there's some old people like me in the group, but the thing I love about SWEETMA is that the majority of the people working with SWEETMA are under the age of 30. That they're young professors, young researchers, soil mappers, as I was. And so it's a really cutting edge part of the soil science community. And it's something that I would encourage you, even if you aren't a soil scientist, as an interdisciplinary, to consider it as a focus for your future research and work. And there's a working group, SWEETMA website that you can go to, and I encourage you to go to it and search out for meetings. You'll find you're very comfortable in those meetings because it's extremely collaborative, as well as forward-thinking and young, and very diverse for coming from the whole world. I find it a lot different than some other meetings I go to that I think, oh, I'm all by myself here. But in this case, I feel part of this group quite definitely. So the book that we worked on, and I worked on it as an editor, and I also contributed a chapter. But they were from people all over the world who contributed. And I think this is a book that you ought to look for if you're thinking about collaborating and looking at material from all around in terms of interdisciplinary activity. And I'm going to go over some pieces of the book since we're limited on time at this point. It'll be very brief. I won't go into the detail I might have gone into in another case. So one of the first things is the second chapter is the main characteristic. The first chapter in the book kind of talks about the history of SWEETMA and how we all came together. But in the second chapter, we start talking about the composition, properties, functions of soil in the urban environment, and from many different angles, and really talking about how we think about classification and some of the most important functions of urban soils. Here are some pictures of some of the composition and how those urban soils might look. Some might look almost natural to you. Oops. Let's go. Some might look almost natural to you, and then others you can see definite disturbances where either through really many years ago, obviously this one might have been several years ago because there's actually some development in the soil. Something that we pay a good deal of attention to when we're mapping. This is from the mapping chapter about soil survey that I worked on with one of my younger colleagues who is working in LA, and how we look at pre-development and post-development, and where you still see the landscape, some of the landscape, the natural landscape. And a lot of these new tools like using LiDAR can really emphasize the original landscape in the profile, and then what it looks like with an urban interface and urban overlay of it. In terms of contamination, we've had a lot of work in this. This professor right here, Shangyi Cheng, he actually goes by Joshua when we speak to him one-on-one, is working with trace metals, and this was one of Dr. Patsleva's emphasis on her PhD. Also, in general, functions of urban environment, thinking through a history of the town and the changes in function in areas and how that might also change the ecology, and thinking through where something is. This is one on heat transfer, and I actually found this paper very useful for thinking for the future on heat transfer and how soils change in terms of their biology because of that heat transfer. And then hydraulic properties of soils, also a very specific but interesting aspect of where you receive materials and how the materials might receive water for infiltration going down through the urban profile, and where the artifacts can really affect, first of all, how the water flows, and then the potential for chemical interactions for reducing and oxidizing the material. In chapter 3, they think about the pedogenic evolution of soils, and this is fascinating to me. This had a lot to do with my soil survey mapping and thinking about that. Pedogenic processes, I think you know about this, but it's, sort of like the geologic history and also the biological history of how a soil comes to be, starting with the 5 soil-forming processes of parent material and climate and topography, and which affects the water movement and the chemistry, and then human interactions and vegetation, all working together to create a soil and its history. And then that history that soil has a marker where we can read those processes in the soil, and that's a whole process of pedogenic or pedology, the study of that history. And so here we have pedogenic processes of urban soils, industrial, traffic, mining, and military areas. We have specific properties of soils underneath pavement construction or soil sealing. We have micropedology of soils, urban soils, where it's very specific to the very smallest the smallest size of soil, where it's aggregated together. And with this, particularly all of human activities affecting everything, here's the 5 soil-forming factors: parent material, climate, topography, organisms, and time, and then human activities altering all of them together, and then the potential challenges or changes, physical disturbances, incorporation of technogenic or new materials, and indurated layer or sealing on the surface. It's a fascinating study, and it involves many disciplines to analyze this kind of work. Here are specific properties that are created underneath pavement construction. This is something that Dr. Patsleva is actually working on, a paper for the FAO, Foreign Ag Service, out of Rome, looking at soil, what we call soil sealing throughout the world, and how that might affect future climate activities and carbon. And then finally, the micropedology of SWEETMA's of urban soils, looking at the micropedology or the thin sections. And for those of you that are chemistry oriented or interested in technology and microbiology, knowing how to do these thin sections is a fascinating activity, and also really does clarify some of the effects of reclamation and how urban soils are put together and how they react with the environment. One of the big groups that we have is classification of urban soils, and this overlaps with some other international groups that I work with that is specifically soil classification. And we have quite a bit of activity associated with that. And then going further with that classification is actually urban soil surveys, of which I've interacted with all of these folks in terms of evaluating their urban soil mapping and how they've approached it. In the case of Germany, this is a typical map. They're working with a different classification system than us in the US, but following many of the same procedures that I actually did with my first soil survey in Baltimore City, in thinking about what are the natural soils, what are the urban soils, and how, and the anthropogenic soils, and how have they changed, and then being able to map that out. Chapter 6 is the management of soils in an urban environment, soils in a green infrastructure, waste capping systems, pedological engineering for brownfield reclamation, and using waste for fertile soils for urban construction. All of these activities, I have found this was a nice overview for me. And then not that long ago, Dr. Patsleva and I worked on a paper on soil sustainability in urban areas, where we worked with an international group to and the Encyclopedia of Soils to create a chapter. And I hope that at some point that we can do a specific presentation on that at some later point. We also have soils and green infrastructure of, and I think many of you possibly could have this as a career sometime in the near future in working with green infrastructure and specifically some of this is engineering and hydrology, but putting it all together to limit stormwater damage in urban cities and also applying it to the suburbs. I always think about one area that I was mapping, and it was out in the countryside, and yet there had been a huge change in the last 5 years with a stream down below where they had put in a small subdivision above it, but just let all the water run off into the stream. And the stream had eroded down to a very old surface and quite deep, and they were trying to renovate it. And this is all about that green infrastructure. Waste capping systems and processes for long-term impermeability. This is the surface sealing, but thinking about it in terms of landfill and treatment plants. It's an important field and involves engineering as well as specifically soil capability. And then pedological engineering for a reclamation field. Here they're working specifically on adding organic matter and recreating a surface soil, and how can they reclaim it within, let's say, a 10-year period. And almost with all mining now and regulations, those mining companies have to reclaim the area in some form to make it useful again. And guess what? They hire soil scientists to do that. Using waste for fertile urban reconstruction also, this is a big question. You know, how much can we use urban waste for reconstruction and revegetating old areas that have been, in urban and sealed areas? And it's still a big question whether sewage sludge is a way to go. The latest is PFAS. I think some of you might know about that, but it's affecting all of the U.S. So all of those Teflon pans that your parents cooked up a storm on are now getting put into landfills and affecting sewage sludge all over the world. And PFAS are in the groundwater, they're in our bodies, they're everywhere. A huge issue for human health. And then soil sealing constraints, benefits, and management, also another piece. Urban agriculture and food security, this is a major item. Garden soils and recovery of strategic metals from urban areas. All three of these are really hot topics. Even though these papers were written about 5 years ago, they're extreme hot topics right now for industrial areas and of interest. So for urban agriculture and food security, it's all interactive and working together. And for the garden soils, looking through garden soils, and then metal contamination and phyto extraction, trying to find ways to extract our metal contaminated soils for reuse. That's the issue, is many of these chemicals, we need to use them again. And even in the case of your cell phones, how do we recycle those materials and find them? They're already in landfills. And how do we recycle those materials and bring them back into use for the future? And then ecosystem services, for those that are biologically oriented, this is an important aspect. And urban soils are, as they become more and more the part of our world, those ecosystem services become more and more important. And those involve carbon storage. I don't know how many of you are interested in carbon, but it's definitely for climate change. It's a focus. Phosphorus reservoirs, biodiversity, ecosystem services for heavy metal contaminated soils, and pollution mitigation, natural attenuation of organic pollutants. So this is thinking about those PFAS as well, the forever chemicals that we've contaminated now, our soils and our water, that need work. And I'm not going to go too far through this because I do want to give you some time for questions, but all of these are important aspects of what we're working with. And PHAs are also related. The polycyclic aromatic carbons are also related to the PFAs, the permanent chemicals. One of the final things in ecosystem services is specifically cultural services provided by urban soils. And there were two papers that were in our book, but they represent just a small aspect of what we have been exploring in terms of urban soils. This one is about the huge landfills that were created in Berlin, associated with the rubble of World War II, where pretty much 90% of Berlin was destroyed and in some form and needed to be rebuilt, but all of the urban materials were just dumped in a big, huge mountain. And then eventually that mountain was reclaimed as parkland and planted. And it's just a fascinating story that is worthy of just reading on its own. But when you think of all the landfills we have everywhere, many of those landfills are full and need to be recycled, in quotation marks. This story is certainly a compelling story, and we saw a similar story in Korea when we visited South Korea, of enormous landfills that they're trying to reclaim into parks and open land and build off of. And then finally, just the beauty of soils and the beauty of urban soils are quite interesting as well. looking at soil art and working through that to make it work through. We've had a lot of activity in soil art, which relates back and forth with the public to interest them in soils as well as improve their thoughts about it. So I'm going to sort of conclude with just some ideas of, I have a friend coming in right now. I have, just to finish things up, there's a lot of aspects of soils, particularly in the urban environment, that no matter what your field is, you can apply and think about, even if it's just in your normal life. In this case, plant choices and the interaction of urban soils, reclamation, biology are all important for creating a new environment and interacting all the disciplines to put that together. For folks, they think it's all about gardening and creating more food, but it is an important piece. And just in my past few years, the composting has been a really important aspect of composting fresh material from renovating in the landscape, but also food waste. A huge field of interest right now is composting food waste for reusing. And when you think that 20% of a lot of our landfills, which are now filling up and are finished, are actually food waste, there's a lot more we can do with that. And it also has to do with urban and anthropogenic soils for working with them. And lots of pictures. I'll just end with this, which is where there's hope, there is a dream. And I think about my career. I always have this story about when I was graduating from the university in soil science. My father got quite worried, and he said, "Oh, what is she going to do with that degree?" And he actually was working. We have a family ranch with apples and cattle, and he went to talk to his local soil conservationist to do, just to ask his advice whether I could have a career in soils and whether it would make any sense. And it was interesting because, all these people are gone now. But the guy, his name was Red White, said that, oh, of course, yeah, that's been my career. I've worked with people. I've worked with the environment. I've worked with farmers. I think there is a career for her there. And then, of course, 20 years, it was probably 20 years later, I actually worked for Red. And I never knew that my father had got it asked. And Red said, "Oh, wow, it's possible. It's possible." And when I look at this picture, I think, oh, yeah, it's totally possible to work with all sorts of people and make it work all over the world. So that's it.